Okay, and here's our third shift in the Common Core standards. It's about rigor, and this is probably my most favorite of the three shifts, but it also breaks down into three pieces. The idea is we really want to raise the standards by being more rigorous. We want to really get to the point where students actually understand what they're doing rather than just memorizing it for the test and letting go of it. And I think that this is critical if we're going to continue pursuing the level of mathematics that we have in our K-12 education system. So I think this is a great philosophy that Common Core has laid out. So to help students meet the expectations of the standards, we're going to have to pursue these three things with equal intensity, so not one more than the other. The first is conceptual understanding. And a lot of people have said that this has got to be the main focus of what we're doing, but really the reason that they're saying that that needs to be the main focus is because number two, our procedural skill and fluency has been our focus for so long. And according to the Common Core publisher's criteria, again, these are with equal intensity. All three of these need to be pursued. So we can't sacrifice the procedural skill and fluency for the sake of the conceptual understanding. We need to have both of them along with the third, which is applications of the mathematics. Because if we have a good understanding of what it is that we're talking about, and we know the skills and are fluent with those skills as we move forward, we should be able to apply them into new and novel situations. So let's break these three things down one at a time. So conceptual understanding is where we want to have questions and problems and lessons that build towards an actual understanding of what it is that we're doing. And so one of the things that they say that this could include is just some brief conceptual problems with low computational difficulty. So we're trying to take out the procedure from it. The example they give I don't think is necessarily the best one, but find a number greater than 1/5 and less than 1/4. You know, that's you can turn that in procedure. You can add them and divide by 2 and you're done. But if we approach it without that procedure in mind, if we say, hey, let's think about this, what would make sense in this situation, rather than jumping immediately to the procedure, then we can build some conceptual understanding with that. Also, this is, I think, a better example here is if the divisor does not change and the dividend increases, what happens to the quotient? Those are the types of brief conceptual questions that we want to pose. And this means that we're going to have, I'm jumping ahead a little bit, but this means on our assessments and in our instruction, we're going to have some word problems on there where students, not only the problem is words, but that the students have to write about the mathematics. We're not going to be able to get to whether or not students understand it unless they can explain things in their own words and communicate the content to us. So we're going to have some word problems in there. This is where myself personally and in my curriculum, I think that we're missing some of these things and we need to bolster that conceptual understanding piece, because I still know that my leaning is towards more the procedural fluency, which is important, but we got to build up the conceptual understanding as well. And then also we can get at this conceptual understanding if students can explain the coherence. So if they can make connections like, hey, this is like that thing and it's like that thing over there, they're going to be able to see that, or we're going to be able to see that they actually understand it. Not only coherence between topics, but coherence even between different representations. So if students can take a quantitative representation, a symbolic representation, and turn it into a picture, turn it into a table, turn it into a word problem, if they can shift between modalities like that, then we can be pretty sure that they actually understand what it is that they're dealing with, because they're able to shift between those modalities and representations. Okay, the next piece is procedural skill and fluency, and this is something that we're probably all familiar with because this is what we've always done. This is kind of the plug and chug. But the procedural skill also comes down to we have to know when to use those skills. If we know how to add, subtract, multiply, and divide, but we don't know when to do that, then it's not really useful. And not only do we want to be able to do that, but we want to be able to do it fluently. And fluently means that it's, we have some ease with the process. There's probably some speed implied in there. Obviously not every kid is going to be a speed mathematician, but if we're laboring for, minutes and hours over some basic computation, then we really don't have fluency even if we can eventually get it done. It's not really fluent for us. We're still in the learning process. So this is going to take some manipulatives probably to be able to connect it to the conceptual understanding. And then from the conceptual understanding, we can build up to the written and symbolic methods, which again, is just another representation of what it is that we're doing. And we're going to need some purely procedural exercises, really. And the Common Core says that there will be an ample number. So if you can see this right here, an ample number of these procedural type problems, and it may just be adding two numbers or solving a system of linear equations. There is no context for these problems. There are no words surrounding these. This is what I call naked math. This is just the numbers and you just crunch it out, okay? Plug and chug. We need to be able to do that to build some procedural fluency. And then one caution, any methods or algorithms that are based on mnemonics or tricks rather than actual principles of mathematics is probably an issue. So we've already talked about proportions and cross multiplying and dividing. There is no such thing as cross multiplying. What we're really doing is, in a proportion, is multiplying by the product of the denominators that are on both sides of the equation there. Another one is FOIL. Okay, FOIL has no meaning outside of multiplying binomials. What it really is the distributive property. We're just using the distributive property, and it would be so much more helpful for students to recognize it as the distributive property as we have built it up over the grade levels. So we start using it at the middle school, they continue using it at the high school, and as they get past a binomial times a binomial, if they've got a binomial times a trinomial, they can still be using the distributive property and see how and why it connects. Where if we're just using FOIL, then it only applies in that one situation and it gets them through that test, but they can't actually take it and push it forward into their education. So procedural skill is not about quick memorization. It still has to be tied to that conceptual understanding to be able to realize its fullest potential. And then lastly is application. So an application means we're going to take this math and we're going to put it into some sort of context. It's probably going to be, it's a single step and multi-step, but we might lean towards the multi-step here, that are going to be able to engage the students in a problem-solving type problem or situation, because we want students to be able to decide what mathematics do I need to use here, what makes sense in this situation, okay, and that's the idea of application. Problems in which students make their own assumptions or simplifications. Dan Meyer had a great thing about this where you just present the problem, no numbers, and students have to come up with numbers. If you put 3 numbers in a problem right now, every student's just going to find a way to work in those 3 numbers. So giving them extra numbers that they don't need, so that they have to decide what numbers are applicable to the situation, or give them no numbers at all and have them decide what numbers do I actually need to be able to solve this, and then as they decide on need, then those can be provided or measured on their own. Also, we're going to need some that are going to problems to be worked on individually as well as classroom activities. So they're going to have to be able to demonstrate this mastery of application on their own, not just with a group. Now we know that interdependence we need to work that in, that we are, the sum of the parts is greater than, or the whole is greater than the sum of the parts rather. So we know we work better together and we learn better together, but by the same token, an assessment implication for this rigor is that we're going to have to know what can that individual student do, how can they apply it, and not just save those for big group learning projects. And then we have to make sure that all these things, again, are grade level appropriate. I like the idea of a sensible trade-off between the sophistication of the problem and the difficulty or newness of the content knowledge. So that, if it's going to be a complex problem, then maybe we've got all content that we know. If it's not that complex of a problem, then maybe we have some new or novel mathematics that they're using to actually learn, and we're using this rigor approach, this application, as a learning task type environment. Okay, some other things about rigor from the publisher's criteria is that the 3 aspects of rigor are not separate in materials. So, usually one or the 2 of them go hand in hand. So you can't fluency is going to be practiced within the context of application. You can't really do anything fluently unless you understand something. So some of these things are always going to tie together, but not always, is what they say in number 2 here, is that they're not always together in all 3 of them. And you will see that when we dig into writing some curriculum specifically about what type of standard is this, where does it fit on the spectrum of the CPA, the conceptual understanding, procedural fluency, or application. Now, ISBE has said that application can come in 2 forms, and one of those is mathematics applied to the real world, and then we finally caved in and said, okay, a lot of this math doesn't necessarily apply to the real world, or doesn't necessarily apply to any real world context in which the students would be familiar with, and so therefore mathematics applied to other mathematics is also considered an application level problem. So that gives us some leeway, so that we find that we don't have to kind of pretend like these silly problems that we say are real world actually are not, like the sheep and the chickens problem with systems of equations. The farmer looks out and he sees the legs and he counts the heads of the animals and how many of each. No farmer is going to do that. They know the difference between a sheep and a chicken, so that's not a real world application. Okay, but it is at least a fake context in which we can put that problem, but it's definitely not real world. So if we can take mathematics and apply it to mathematics, that really is an application. So what other instructional implications do we have here? Well, we want to balance the CPA in our classroom instruction. That means we got to think about at what level is this? Is what I'm teaching really about conceptual understanding? Is what I'm teaching really about the procedure, or is it really about the application? And we're going to have to utilize both problems and exercises to get students to mastery level learning of the different standards. Students are probably going to have to make their own assumptions, which we talked about, simplify things, and then we also want to be very explicit with the vocab that we're using, and consistent across grade levels. Again, that's the coherence piece coming back up, but if we're continuing to use that mathematics vocabulary, that's going to build rigor, because the students are going to have a better conceptual understanding of what's going on, and to be able to then apply the correct procedures in any given situation. Also take advantage of what's called cognitive disfluency, or desirable difficulties. Sometimes most times we learn best when things are difficult. When we have a problem with something, that's when we're really going to learn it. In fact, they went so far, one study that I read went so far as if you take a homework assignment and you photocopy it for students, if you shake it a little bit on the photocopier and it's harder to read, just the fact that it's fuzzy and harder to read, and the students had to actually think about it a little bit more, help them learn that content a little bit better. Now, I'm not saying go do that in your classroom, but I do want you to get the idea that if something is difficult or hard to do, that's good. Okay, and right now students are of the mindset that if it's difficult or hard to do, that they shouldn't do it because it's too hard, and that's what we got to work them out of that. We want these desirable difficulties. We want chances for productive failure. We want ill-structured problems. Okay. So in our assessment, we've got we're probably going to need some formal, observational, formative assessments. And so that means we're going to actually have to plan those formative assessments and at the levels that we need them of the CPA. Summative assessments are going to need a balance of the CPA levels as well. We might ask students to find an error in a problem. Rather than just solving a problem, we might have them look at some work and analyze for the error. That's going to help get to, do they actually understand how the procedure works? And assessing conceptual understanding, conceptual knowledge, is again going to take some discussion or some writing for students to do. Alright, so we're going to start heading into how to build a scope and sequence document and how to really start getting the curriculum running at this point, so join me for that one.